Greetings everyone and welcome to the chemistry program. I am delighted to be here today to discuss this topic. Today I will be discussing the wonderful and the marvelous world of chemistry. Today I am going to talk about the galvanic cell and production electrical energy. The galvanic cells and producing electrical energy. The galvanic cells are systems that produce electric energy through spontaneous redox reactions. Galvanic cells are divided according to their nature to produce electrical energy into two types, which are primary cells and secondary cells. First, primary cells. What about the primary cells? What are the characteristics of these cells? Characteristics of primary galvanic cells. Number one, these are saving energy systems in the form of chemical energy, which can be converted to electrical energy through spontaneous irreversible redox reaction. Number two, stop to work when the anode materials is consumed and the ions of the cathode half cell are diminished. Number three, they not only easy but also impossible to be recharged to returning its constituents again to its initial state. This means that it is an irreversible cell. Irreversible cells. It should be in dry form, not in liquid, to be easy use in mobile equipment. It is known as dry cells. It is known as dry cells. It realizes a constant potential for a long time working, in addition to the possibility of its manufacture in small size. For example, mercury cell. Mercury cell is an example of a primary cell. What about this cell? This shape or this figure represents a mercury cell. And in this shape, we can identify the anode and the cathode and the electrolyte. Zn anode, HgO plus graphite. Cathode, KOH represents an electrolyte. Okay. Its properties and uses. It is manufactured in shape of cylinder or disc. It has a small volume. It is commonly used in earphones, clocks, and cameras. Its composition. What about the composition of this cell? Mercury cell. The negative pole, which represents the anode, is zinc, Zn. While the positive pole, which represents the cathode, is from mercuric oxide. The potassium hydroxide is used as an electrolyte in the cell. Potassium hydroxide, KOH. The total reaction occurring in this cell and its potential are Zn0 plus HgO to give ZnO plus Hg0. This represents the total reaction that takes place in mercury cell. E cell or the EMF of this cell equals 1.35 volt. This all about mercury cell. The anode, the cathode, the electrolyte, the total reaction, and the EMF. You must know these very important knowledge about any cell. The anode, again, the anode, the cathode, the electrolyte, and the E cell, and the total reaction. The second example of these cells is fuel cell. What about the fuel cell? This figure represents the structure of the fuel cell. Hydrogen burns in oxygen. We know that hydrogen reacts with oxygen to form water. Hydrogen burns in oxygen of air strongly, giving light and heat. Giving light and heat. 2H2, according to this reaction, 2H2 plus O2 to give 2H2O. 2H2 gas plus O2 gas to give 2H2O vapor. Plus energy. Energy is in the form of light and heat. Light and heat. Scientists could carry out this reaction under certain conditions which can be controlled inside what is known by the fuel cell. Can be controlled inside what is known by the fuel cell. This type of cell is preferable in the spaceships. Why? Why this type of the cell is preferable in the spaceships? Because its gaseous fuels, which are the mixture of hydrogen and oxygen, is the same fuel used in launching rockets. Its composition. Now, this video will illustrate hydrogen fuel. In this figure, we will observe what happened in this cell. Gas, hydrogen gas and oxygen gas enters in this cell, and hydrogen oxidizes. As you see, hydrogen enters to its room and oxidizes, as you see, to change into positive ion, positive hydrogen, and the electrons transfer in the external circuits to another electrode which contains oxygen. Hydrogen plus oxygen react with each other to form water. As you see, H2O. Hydrogen react with oxygen to form H2O. This video illustrates what happened in the fuel cell. Hydrogen oxidizes while oxygen reduces. Hydrogen changes into positive ion while oxygen it changes into negative hydroxide ions, and the positive hydrogen ions reacts with negative hydroxide ions to form H2O. It is made from two pools. Each of them is similar to a hollow container lined by a layer of porous carbon that connects between the internal room and the electrolyte that exists inside it, which is hydrated potassium hydroxide. Hydrated potassium hydroxide, KOH, it is the same electrolyte in mercury cell. So they are similar in the electrolyte only. Now this video, another video that illustrates how does this cell operates. How does this cell work? The modern car used the fuel cell, and this represents hydrogen tank and the fuel cell. When the car moves, what happens? This cell, the reaction takes place in this cell. Negative electrode, positive electrode, and at negative electrode, which represents the anode, there is hydrogen. Hydrogen oxidizes, while at positive electrode, which represents the cathode, there is oxygen. And the electron transfer from hydrogen to oxygen, as you see in this figure or in this video. H2O is produced. After the reaction, H2O is produced. Okay. Now we will identify the reactions in the fuel cell. What are the reactions that takes place in the fuel cell? At anode, oxidation reaction, H2 gas plus 4OH negative aqueous to give 4H2O liquid plus 4 electron negative, and the anode or the oxidation potential of hydrogen equals 0.83 volt. At cathode, reduction reactions takes place while O2 plus 2H2O comes from the electrolyte plus 4 electrons comes from the anode to gives 4OH negative aqueous, and the anode equals 0.4 volt. What about the total or the overall reactions in this cell? How can you write the total reaction? As you see, 2H2 gas plus O2 gas to give 2H2O vapor, and the E cell equal the summation of the value of oxidation and the reduction potentials equals 1.23 volt. Now we will identify the properties of this cell. What about the properties of these cells? It can't be consumed like the other galvanic cell, primary galvanic cells. It can't be consumed. Why? Give reason. Because it is supplied with fuel from an external source. It is supplied with fuel from an external source. It gives an electric current with EMF or E cell equals 1.23 volt. Number 3, it operates at high temperature and the produced water evaporates and can be condensed to be reused as drinkable water for the astronauts. It doesn't store the energy like the other batteries. It doesn't store the energy like the other batteries. Give reason. Because its work requires a continuous supply with the fuel and a continuous remove of the products. Now we will identify the secondary cells. We will talk about the secondary cells. Now we will talk about the secondary cells. They are characterized by reversible chemical reaction. They store the electrical energy as chemical energy, which can be converted once again to electrical energy when it is needed. They can be recharged by passing an electric current from an external source between their poles in a direction opposite to their discharge process. For example, what about the examples of the secondary cells? Lead acid battery. Lead acid battery. It is called car battery. Why? Because it is developed and becomes the most suitable kind of batteries used in cars. It consists of 6 cells, are connected in series. Each cell produces 2 volts. So the total volt in these cells equals, and the total cell potential of the battery is 2 times 6 equal 12 volt. It is possible to manufacture large volume batteries contains more than 6 cells when it is needed. Its composition. What about the structure? What about the composition of this cell? The anode, the cathode, the electrolyte. An external container made of solid rubber or plastic, which is polystyrene, which isn't affected by acids. Why acid? Because the electrolyte is high sulfuric acid. The anode is network of lead filled with sponge lead, Pb. The cathode is lead network filled with a paste of lead dioxide, PbO2. The plates are separated from each other by insulating sheets, and all of which are dipped in dilute sulfuric acid solution as a conducting electrolyte. Now we will talk about the discharge process, discharging reaction. What about the discharging reaction? In this reaction, the cell makes as galvanic cells. At the anode, Bb plus SO4 power negative 2 comes from the electrolyte to give BbSO4, which is a precipitate insoluble in water, plus 2 electron, and the E node equals 0.36 volt. At the cathode, PbO2 plus 4H positive plus 2 electrons to give PbSO4 insoluble in water plus 2H2O, and the E node equals 1.69 volt. 4H positive comes from the electrolyte. 2 electron negative comes from the anode. The cell works here as a galvanic cell, and at discharging, the total battery reaction is Pb plus PbO2, the overall reaction, Pb plus PbO2 plus 4H positive plus 2SO4 power negative 2 to give 2PbSO4 plus 2H2O, and the E cell equals 2.05 volt, approximately 2 volt, approximately 2 volt. Okay, the EMF equals 0.36 plus 1.69 equals 2.05 volts. The battery state can be identified by measuring the density of the acid solution using hydrometer. What about hydrometer? What do you know about hydrometer? Hydrometer is a substance, is a tool that is used to measure the liquid density. When the battery is completely charged, the density of acid equals from 1.28 to 1.30 gram per cubic centimeter. And if the acid density decreased to lower than 1.2 gram per centimeter cubic, this means that the battery needs to be recharged and increase its acid concentration. Now we will talk about the charging process, the charging reaction. What do you know about the charging reaction? Using the battery for long period leads to decrease the concentration of sulfuric acid. Why? As a result of increasing the quantity of water produced from the reaction, and also leads to the conversion of the cathode material, which is PbO2, and the anode material, which is Pb, to lead to sulfate, which leads to decrease the quantity of electric current produced from the battery. Here, the battery needs to be recharged again, and this is done by connecting the battery poles to an outside source of direct electric current, whose potential is slightly higher than the potential produced from the battery. This will lead to the reversing of the spontaneous reaction which occurred during the discharge of the battery, and will lead to conversion of lead to sulfate PbSO4 to lead Pb at the anode and the lead dioxide PbO2 at the cathode, and the concentration of sulfuric acid is renewed as it was. The reaction resulting from the charging process can be illustrated by the following reflective equation or reflective equation. 2PbSO4 plus 2H2O charging process to give Pb at anode and PbO2 at cathode plus 4H positive plus 2SO4 negative 2. The reaction is a non-spontaneous reaction and requires external potential. The battery acts in this case as an electrolytic cell. This means the storage of electric energy which comes from the external source in the form of chemical energy. This is why the secondary cell considered as storage batteries. In the car, the dynamo in a continuous way is used in recharging the battery first by first. Lithium ion battery. The last example on the secondary cells is lithium ion battery. It is a dry and rechargeable battery. It is used in mobile and laptop. It is used in modern cars instead of the lead acid battery. Why? Because it is lighter and store large amounts of energy. Because it is lighter and store large amounts of energy, while it is a small in size. Due to 3 reasons. Okay. The reasons for using lithium. Why we use lithium in this cell? Why don't we use sodium, potassium? Why we use lithium? Because it is the lightest metal. It is the lightest metal. And it has the lowest reduction potential, negative 3.04 volt. So it has the highest oxidation potential, and it is the most active metals. It is the most active metals. Now we will talk about its component or its composition. First, you must watch this video. In this video, we will observe the structure of this cell, lithium ion battery, the structure and its function. This battery, this is the constituent of this battery: aluminum foil, copper foil, cathode and the anode, as you see, and there is an insulating between anode and cathode, and this cell can be used in a lot of equipments such as laptop, mobile, lithium ion battery. We can use it in a very important equipment. Separators that separates between anode and the cathode. Okay. Positive lithium, as you see, positive lithium moves in all directions during charging and discharging, and it changes its direction by changing the type of the cell. As we came to the end of our program, I hope everyone found it interesting and had a good time watching us. Thank you, and till we meet again, I wish you the best of luck.